Hello, today we're going to present the knowledge graph creation pipeline developed by the TIB SDM group. First, let's talk about the domain ontology. The domain ontology, or simply ontology, defines the entity and classes as well as relationship and attributes used for during the knowledge graph creation process. For this example, we're presenting an ontology reflecting the disaster data set. This ontology can be found in the link on screen. Here you can revise the different entities, relations, as well as playing with the different molecule templates. Next, let's talk about the data sources. In this case, the data sources can be CSV files, JSON files, or relational databases. In this case, we utilize relational databases which are represented as tables. These tables correspond to different sort of entities, as well as presenting different attributes that will then be used for the knowledge graph creation process. The knowledge graph creation pipeline is presented as a series of Docker images which can be downloaded each individually or downloaded together in a single container. Each component requires their own input to be fully utilized. Now we will show a very simple way how to execute the pipeline while having a Docker compose with all the Docker images. To be able to generate a knowledge graph, one needs to generate mapping files. Given the tools that are used for this pipeline, the language that is utilized is RML. RML, or RDF mapping language, is one of the most commonly used mapping languages today. The mapping must follow the rules established by the ontology as well as utilizing what the data sources says. What I mean by this is that a mapping must utilize the same name and attributes as well as respecting the existing relationship within the data. Now, let's talk about the first component of the pipeline, Dragoman. Dragoman is a mapping interpreter that allows the user to transform mapping rules with functions into equivalent in mappings without functions, as well as transforming the data so to reflect these changes. By doing this, Dragoman executes the functions that are defined in the mapping and then generates and projects the data sources to reflect the result of the executed functions. This By applying this engine, this acts as a certain level of pre-processing for the data, which can be utilized to remove elements that the user does not want or to generate new values that previously did not exist within the data. Of course, since these mappings have functions, the mapping language in use is an extension of RML, which is called RML plus FNO. The FNO part actually is the extension that defines the functions, and the functions need to be implemented within Dragoman to be able to execute them. The main idea is to first define the functions, have an idea what they should do, and then implement them in Dragoman. The parameters of the function defined in the mapping must be reflected in the parameters defined in Dragoman. Dragoman requires a configuration file to be executed. This configuration file informs the tool which mappings will be transformed, as well as different parameters that it requires to function. Now, the next component is the actual component that generates the knowledge graph. The SDMR devicer is a knowledge graph creation tool that follows the rules established by the RML mapping language. It is capable of transforming multiple data sources, as well as having multiple data structures within it, as well as novel operators that optimize different aspects of the knowledge graph creation process, as like the duplicate removal and execution of joins. The same as Dragoman, the HTML devicer requires a configuration file that gives the necessary information to be so that the artifact can function, like where's the mappings, what sort of data source that will be used, if it's a relational database, is the necessary credentials, if the user wants to have everything in one file, or the user wants to remove duplicates. For this, it's necessary to use RML mappings and to have the corresponding data locally. The resulting knowledge graph given our current example can be uploaded to a knowledge graph uh, storage or triple storage. This can be either virtuoso or the tool that we are currently using, which is GraphDB. In this video, we present a sort of tutorial how to upload knowledge graph into GraphDB. From there, you can execute queries as well as visualize different components of the knowledge graph, as well as seeing the particular molecule template. Now let's talk about the next component. This is Trap Shaka. Trap Shaka is an engine that validates the correctness of a knowledge graph. How does this engine do this? By defining shackle shapes that allow to determine what should a valid entity look like. For example, an event has to have up to one date or have to have up to one name. These things need to be defined so that a knowledge graph can be validated. And if these knowledge graph respect these things, it's a valid knowledge graph. Well, thank you very much for your attention.